Hello everyone, this is Vijay Lakshmi Sugnali from WinMaths. In this session, we have discussed the exercise problems on relations and functions, exercise 1.2. Here, already discussed first to 7 questions on this exercise. Now, the continue part of this exercise, the next question was 8. Here, A and B two sets show that a function f from A cross B tends to B cross A, such that a function f of A comma B is equals to B comma A is a bijective function. Have to shown or prove a function f from A cross tends to B cross A is a bijective function. Here, first, have to consider A cross B. It is Cartesian product of A and set B. Here, in this set, there are two non-empty sets. A and B are two non-empty sets. Their Cartesian product. Okay, the function from Cartesian product of A cross B tends to Cartesian product of B cross A. Then there exists a function f of A comma B is equals to B comma A. Here, now consider two sets. That is, A is equals to 1 comma 2 and B is equals to A comma B. Here, A and B are two sets. Then their Cartesian product have to written here. Cartesian product of A cross B is equals to 1 is related with A and 1 is related with B. Again 2 is related with A and 2 is related with B. That is 1 comma A, 1 comma B and 2 comma A, 2 comma B. This is the Cartesian product of A cross B. Again, now B cross A is equals to, here first element have to taken from set B and second element should be taken from a non-empty set A. Here A is related with 1 and again A is related with 2, B is related with 1 and B is related with 2. Okay, now checking the condition. Here checking the condition, f from A comma B is equals to B comma A. The elements of A and B, the function of elements of A and B is the result B comma A. For this one, we have written for the first order pair A cross B. Okay, because the domain should be A cross B and codomain should be B cross A. Here consider and codomain set. Okay, domain has the order pair. This is A cross B and this is codomain B cross A. Here consider A cross B, that is 1 comma A, 1 comma B, 2 comma A, 2 comma C. Okay, here B cross A becomes A comma 1, A comma 2, B comma 1, B comma 2. Okay, from we have taken 1 comma A in that function, then their image should be first function taken as B, that is A comma 1. Again for the element 2, that is 1 comma B is equals to B comma 1. 1 comma A, substitute we get A comma 1. Again this is related with B. Again this one is related. The last element is also related. Here whatever the we taken the elements from Cartesian product A cross B, then we get the images are taken from the Cartesian product B cross A. Here it is satisfied. Okay. Now theoretically we have written, that is, consider first have to prove the one function. Now one let f of x1 is equals to b1 comma a1. Again f of x2 is equals to b2 comma a2. Therefore f of x1 is equals to f of x2 for every x1 and x2 are belongs to Cartesian product A cross B. Now f of x1 means b1 comma a1, f of x2 means b2 comma a2. We know the result points. The first element is always equals to second element, and first element is always related with first element in order pair, and second element is always equals to second order pair in the second set. From these note we can say b1 is equals to b2 and a1 is equals to a2. Therefore f is 1. Again check the condition for onto. Okay, checking the condition onto here. Now consider the function a comma b is equals to order pair b comma a. That should be our f of x is equals to b comma a. For every b comma a elements are belongs to b cross a, that is b comma a elements are the Cartesian product of b comma a. Therefore replace f of x by y should be order pair b comma a. Okay, b comma a. In this diagram every element has the image. Okay, whatever the elements are have the image, therefore all the elements in codomain also has the one and only one unique image. Therefore this is possible. This is possible. Hence f is not. Therefore we can say f is bijective function. F is bijective function. Clear? Now the next question number 9. Let a function f from natural number to natural number. Here domain and codomains are both are natural number, can be defined by f of x is equals to n plus 1 divided by 2 if n is odd. Wherever we have taken n value becomes odd number, for example 1, 3, 5, 7 up to so on. Okay, whatever the n value we have taken is odd, then replace the n here n plus 1 divided by 2. If n is even, again we put the value n divided by 2 here. For all n belongs to natural number, state whether the function f is bijective. Justify your answer. Here first consider the function. Consider the function f of x is equals to n plus 1 divided by 2 whenever if n is taken as a odd number. Again f of x is equals to n by 2 if n value taken as a even number. Here, for example, here the domain set, that is natural number, again codomain, that is also natural number. For example, natural number starts from 1, 1, 2, 3, 4 up to so on here. Okay, here also natural numbers according to the result we have written after that. Okay, now f of x is equals to, while taken n is equals to 1. N is equals to 1 is odd number, we have used one value here, 1 plus 1 divided by 2, that is equals to 2 divided by 2. 2 get cancelled. Here f of x is equals to 1. When we substitute n is equals to 1, we get the image 1. Again, for n is equals to 2, we taken the result n is equals to 2. F of x is equals to, here n is even, so 2 divided by 2 is equals to 1. Because 2 get cancelled, we get the result 1. 1 has the image 1. Again 2 has the image 1. Okay. From the ray diagram, all values checking is not necessary. Here we get 2 values. It is enough for proof. From ray diagram, we can say f is not 1 1, because since f of 1 and f of 2 have the value 1. Okay. Now it is not 1 1. Again check the condition for onto. Check for onto condition. Now here f of n is equals to n plus 1 divided by 2 if n is odd. Again n by 2 if n is even. Here there are 2 cases. Okay, in this problem they have 2 cases, that is case 1. Consider f of n is equals to n plus 1 divided by 2. Okay, now solve for, here other than x we taken as n, so solve for n. Taken f of n is equals to y is equals to n plus 1 divided by 2. 2 is here, 2y is equals to n plus 1, then 2y minus 1 is equals to n. Whatever the value taken as y, we get natural number. Here check, put y is equals to 1. Here put y is equals to 1. 2 into 1, 2. 2 minus 1, 1. 1 is natural number. Again taken y is equals to 2. 4 minus 1, 3. Whenever the values we have taken as y, we get the natural number which is belongs to natural number. Okay. Again check the second case. F of n is equals to n by 2. This is case 1 for odd condition and case 2 for even condition. Y is equals to n by 2. So n is equals to 1, which is also natural number. Whatever the values taken as natural number, then again we get the natural number. from these two cases, okay, 2n is also belongs to n. Thus for any or for every value y belongs to n, then there exists a natural number x, which is natural number. F of n is equals to y. Hence f is onto. Therefore f is not 1 1, but f is onto function. Here the function is not a bijective function. The next one question number 10. Okay, question number 10. Let a is equals to real number except 3 and b be a non-empty set real number except 1. Consider the function f from a tends to b defined by f of x is equals to x minus 2 divided by x minus 3 is 1 1 and 2. Okay, it means a non-empty set A. Okay, here domain and code. Here domain is the set R minus 3 and codomain be a set R minus 1. Okay, consider the function f of x is equals to x minus 2 divided by x minus 3. If why they given r minus 3? Here we consider x value becomes 3, 3 minus 2 value 1. But in denominator 3 minus 3, 0. Anything divided by 0, the value becomes infinity or not defined. Other than, it means r minus 3 means other than 3 we get the result. When we substitute x as a 3, we can't get any result here and we can't define any function. That's why they given r minus 3. Now check the condition for 1 1. Okay, now check the condition for 1 1. First, f of x1 is equals to f of x2. F of x1 is equals to x2. Forever x1 and x2 value belongs to r minus 3. Okay, again f of x1 is equals to x1 minus 2 divided by x1 minus 3, that is equals to x2 minus 2 divided by x2 minus 3. Okay, again cross multiply x1 minus 2 into x2 minus 3, that is equals to x2 minus 2 x1 minus 3. I have taken cross multiplication. X2 minus 3 taken here and x1 minus 3 taken here. Again multiply x1 into x2, x1, x2, x1 into minus 3, 3, x1 minus 2 to x2, 2, x2 minus into minus plus 2 into 3 becomes 6. Here also same, x1 into x2, x1, x2, x1 into 3, that is 3, x2 minus 2, x1 minus into minus plus 6. Here x1, x2 get cancelled, plus 6 get cancelled. Here 3x1 minus 2x2, that is equals to minus 3x2 minus 2x1. Here there is a minus 3x1 minus 2x2 here. Taking minus 3x2 is left side. It becomes 3x2 minus 2x2. Again minus 3x1 is taken for right side. It becomes plus 3x1 minus 2x1. x2 minus 3 minus 2, 1. That is x2 is equals to x3 minus 2, 1. x2 is equals to x1. Therefore, we can say x1 is equals to x2. Hence, f is 1 function. Forever, x1 and x2 belongs to r minus 3. Again, check the condition for onto. Onto condition. Here, onto means every element has the image for real number. Every element has the image from real number except 1. Except 1, all values are having the image. Okay, check now. Taken f of x is equals to y, that is x minus 2 divided by x minus 3. Again now solve for x. Y is equals to x minus 2 divided by x minus 3. Again taken cross multiplication. Y into x minus 3 is equals to x minus 2. Okay. Y into x minus 3y plus x is taken here, minus x, plus 2 becomes minus 2 becomes plus 2, then 0. Here we have solved for x. That's why taking x common from these two equation, x taken common, y minus 1 minus 3y plus 2 is equals to 0. Again x, y minus 1, all values are taken for right side, that is equals to minus 3y here, that is plus 3y, plus 2 becomes minus 2. Again we have solved for x, that's why x is taken here, y becomes 3y minus 2 divided by y minus 1. Okay, x is equals to 3y minus 2 divided by y minus 1. Whatever the values taken here, we get the real number. If for example y is taken 1, 1 minus 1, 0, we can't define the function. That's why they given r minus 1 here. Okay, r minus 1 here. Other than 1, we get the values. Therefore, it is belongs to r minus 1. Hence, f is onto. Therefore, f is bijective function because f is 1 as well as onto. F is bijective function. Okay. Now, there are two questions, multiple choice questions. Question number 11. Let a function f from r tends to r be defined as f of x is equals to x to the power 4. Choose the correct answer. Here r and r are the real number. Here the condition is that f of x is equals to x4. F of x is equals to x4. Okay. Then x4 can be written as f of x is equals to x4. x4 can be written as x square whole square. Okay. X square means it has plus root and minus 2 root. Okay. F of x is equals to x square as well as other than square. Okay. Now consider square. F of 1 is equals to 1 to the power 4. That is 1 to the power 4, 1. Again, for f of is equals to minus 1. Minus 1 to the power 4 becomes 1. F of 1 and f of 1 has the same image. That's why f is not 1, 1. So, first option have to neglect and f is 1, 1. Second option is also neglected. Again, checking the condition of onto. Here, f of x is equals to x to the power 4. Again, solve for y. F of x is equals to y is equals to x to the power 4. Solve for x. X is equals to 4th root of y. 4th root of y, not a real number. Okay. 4th root of y is not a real number because the negative values have the imaginary roots. Okay. Therefore, it is not a real number. Hence, it is not onto. If here in this option they given onto function, it is not onto, then the correct answer is f is neither 1 1 nor onto. We check the multiple questions while using or taking the values for, and after for that values we have taken. Again, here consider, let a function r tends to r be defined as f of x to the power 4. Then choose the correct answer. Again, choose the correct answer. Sorry, here both questions are same. It is 3x. Okay, it is 3x. F of x is equals to 3x. Now check the 1 1 and onto condition. Here f of x is equals to 3x. For example, domain and codomains are real numbers. We have substituted the values. Put x is equals to 1, we get 3. If x is equals to minus 1, we get minus 3. Okay. Whatever the value given, their answer become differ. It is a unique values. Hence, f of 1 get plus 3. F of minus 1 has minus 3. Therefore, f is 1 1. Okay. F is 1 1. F is 1 1 means it not be many one function. Okay. Now, f is neither 1 1. This option is also neglected. Only two options are left here. We check for onto condition. F of x is equals to 3x. Solve for x. Replace f of x is equals to y, 3x. X is equals to y divided by 3. Y divided by 3 is also real number. Okay. Whenever we have taken y, we get the real number. Hence, it is onto. Therefore, the option C neglected. The correct option is F is 1 1 and onto. Okay. Up to this, the 1.2 exercise will be completed.